We're looking now at a problem involving the area of a kite. Remember again, area of a kite is 1/2 d sub 1 d sub 2. We're given the area of the kite, and we're told that one diagonal is twice as long as the other diagonal. So if I was to draw this kite, doesn't have to be exact. We just want a picture to represent it. If I was to draw it, here's one of the diagonals, here's the other diagonal, and if we call this diagonal right here, if we call it x, then this diagonal has to be 2x. So if we rewrite this, we know that this side is 1/2. We'll call one of them x, we'll call the other one 2x. And we know that the area is 72.25. So therefore 72.25 is equal to, if we cancel those out, x squared, and then at that point we take the square root of both. By the way, I kind of know the answer, at least narrowed down to 2, it looks like. We know b is out because one diagonal is twice as long. We know this one's out as well because one diagonal is twice as long. So it looks like it's either this or this. And my guess would be this one right here, just because we're not going to get 6 out of that. So you can kind of see, if I do 72.25 and I take the square root of that, we end up with 8.5. So x is equal to 8.5. And if we do that with 2x, remember that means that that's the same as 2 times 8.5, which would be 17. So since we have 8.5 for one and 17 for the other, our answer in this case is C. And again, we're going to draw a picture. There's the picture. There's the formula. We plug in x, 2x, and the 72.25. Simplifying and square rooting, we get 8.5. The other one is twice as big, or 17. Alright, here's another one. If you notice, the shape is a, what's it called? Is a trapezoid. So each of these blocks is 10 square meters. So if we look, we've got 1, 2, 3, 4, 5, 6, 7. That makes this 70 meters. We can see that this is 1, 2, 3, 4, so that makes this 40 meters. And then we've got 1, 2, 3, 4, 5. That makes this 50 meters. Therefore, our formula is 1/2 the height times base 1 plus base 2. Let me try that b over again. There we go. And the height here is 50, and that's equal to 40 plus 70. Do half of 50 is 25. So we get 25 times 110. And if we do 25 times 110, we get 2,750 square meters. Okay? So again, we found all the lengths, just counting. Okay? Plug everything in, we get our answer. Here's another one. We have a kite where the area is 80 square feet. This time one diagonal is 4 times as long as the other. So that means, I'm not going to draw a picture this time. We're just going to work it out. Here's our formula. This is 80 here. And over here we would have 1/2. If we call the first one x, the second one would be 4x. So if we simplify this, those cancel to give me 2 here. And we get 80 is equal to 2x squared. I'm going to divide both sides by 2. We're going to get x squared is equal to 40. And if we take the square root of both sides here, x is equal to square root of 40, which is square root of 4 times 10, which is also 2 rad 10. So that's the length of one of the diagonals. The other diagonal would be 4 times that. So that would be 4 times 2 rad 10, or 8 rad 10. I don't know if they want the decimals there or not, but that's what we're going to give. So we get 2 rad 10 and 8 rad 10. Good. Here's another one. We're probably going to want to draw a picture of this, so I'll see what I can do real quick. If they give you one like this. Let's see. So we got 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 1, 3 here. We've got 1, 2, 3, 4, 5 here. 9, 3 here. And 5, 1 here. Whoops, I'm off a little bit. 1, 2, 3, 4, 5 here. And 5, 1. So this looks like it could have been complicated, but it's not really. Because all we really need to do is find the lengths of the diagonals. And if you notice, the diagonals are going to be horizontal and vertical. So, and we can just count this, or we can use the absolute value of the distances. We look at these two right here, n to q, where, whoops, I'm sorry, where this is n and this is q, and it looks like this is m and this is p. So if I'm doing this diagonal right here, you look, they both have 5 for the x's, and so it would be 5 minus 1 here, or 4. To find the second diagonal, we've got m and p, and you notice they have the same y coordinates, so this would be 9 minus 1, or 8. That means for the area, again, it's 1/2 d sub 1 d sub 2. It's 1/2 4 times 8, and if we cancel those, we end up with 16 square units. Okay? There you go. And you're set. Thanks.